Thanks, Simon. Kia ora. Yeah, I'm Craig. It's nice to meet you all. And I do work for Coordinates. And I realized yesterday that I've been working for Coordinates for 18 years exactly. So now 18 years in one day. But I'm here to talk to you about Kart, which hasn't been around quite that long. Hands up, who's used Git? Cool, pretty much everyone. Has anyone not used Git? Cool, okay, thank you. Yeah, not everyone's a software developer and not everyone's used Git. So I'll try and keep it, try and make it make sense for those people as well. But basically, Kart is Git for geospatial data. It stores geospatial and tabular data. It's a tool for version controlling your data. And it can handle tabular data, it can handle vector data, and it can also actually handle raster, tiled raster datasets, tiled point cloud datasets as well. It's totally free, GPL licensed, and it's a lot like Git. In fact, it has Git inside it. And so Kart repositories are Git repositories under the hood. Unlike Git, so in a Git repository you have a working copy, which is to say you've got a bunch of files on disk that you can edit. In Kart you have a working copy, but it's not a bunch of files, it's a database. By default with Kart it's a GeoPackage, but it can also be another kind of database, like a Postgres database or something. Which means you can open your data in QGIS or some other tool and just edit it without any special software. You don't need something that supports Kart in order to be able to edit your data. When I said it's free, I mean it's open source, and in the spirit of open source, should acknowledge that Kart has a bunch of other stuff inside it. It wraps all of these things and more. So, you know, we stand on the shoulders of giants, which is pretty cool. So, why would you do this? Why do you need version control for your geospatial data? Well, for the same reasons that version control is awesome for code, it is also awesome for data. So when your data changes, you want to know who changed it, why they changed it, ideally, that's the tricky one, and what exactly they changed. If you screw something up, you want to be able to see what you screwed up and maybe reason about it a little bit, so it'd be good to tell who did it and when they did it, and maybe they wrote some message about why they did it. Sometimes you screwed something up weeks ago and you're only just discovering it now, so it's not going to be in your undo stack in QGIS anymore. So it's good to have a record of what that was. Basically, we want to treat data like money. Everything, you basically want to be able to account for what's happened, just like you would in a bank statement. Here's a list of the features. This is just a screen grab from the website. I won't walk through all of it. But some of these things are just inherited from Git. Branch and merge, full change history, synchronized data down there, those are all just Git features. And the rest of it is something that we've built on top of Git. And rather than walk through all of them, I'll just show you how it works. So here I am making a new Kart repository. Just create an empty directory, type Kart in it, and now you have a Kart repository with nothing in it. So we better put something in it. If we have some data lying around, we can import it. So here I am importing some data. So I've got a GeoPackage with some data in it, and I want to import it, Kart import that thing, and I passed it islands as the second word there. So I'm importing the islands table from that GeoPackage. And when I type ls to see what's in my current directory, I can see I've now got a GeoPackage lying around right here. That's my working copy. So I can open that with QGIS and see what's in it. Kart can also tell me what's in it. Kart data ls tells you I've got islands in there. Right, so my working copy is just a GeoPackage. That means I can just drag it into QGIS or load it up via my QGIS browser, see what's in it, can edit it, play around with it. Here I've added a new island. Something funny happened and now there's a new island in the middle of the sea. So if you edit stuff in QGIS and you hit save, then you can see it in Kart. Kart's showing me here, there's a new island called Test Island. The diff is I've added one feature. I'm just going to note that this here is human readable, but you can also just pass -o JSON to just about every Kart command and it will give you something that you can parse, which can be useful if you're building this into a CI pipeline or some ETL process. But you might immediately notice a problem with this. We can't really tell what's going on with that geometry. We can tell it's a multi-polygon, but Kart's hidden all of the numbers because it's just going to fill up our whole screen with numbers. And even if it did show the numbers, I wouldn't be able to make much sense of it. Just be a bunch of numbers. So we built in a visual diff. If you add -o HTML, it'll open your browser and show you a little map with your changes on it. All the deleted and added things will be in there. So you can see, this guy has messed up the North Island, he's made a big mess of it, or whatever. Anyway, but now that you're happy with your change, you will want to commit it. And so you just type cat commit. So just a side note, if you're not familiar with Git, a commit is a snapshot of your database, of your working copy, at a point in time. You can think of it like saving your changes. How often do you want to save your changes? When do you want to do it? You want to do it whenever your changes make sense. Frequently committing is generally a good idea. If your changes don't yet make sense, maybe just don't commit it yet. And when you commit, you should add a message. Cat will make you make a message. If you don't supply a message on the command line, it will open an editor and you can type in a message. And having a meaningful why you did this change is a good idea, because you can come back to it later and see why you did it. Speaking of coming back to it later, so you can type cat log and you see something very similar to what you might have seen in Git. In fact, I think we just call git log or something like that. Although we do add JSON output as well, like I said. But this is just a log of what's changed. You can see all the commits and what order they came in. And if you wanted to look at a particular one, you could type cart show and then give it that big hash thing, and it will show you the diff just like cart diff did. Kart also has branches. These work exactly like Git branches. Again, we might have just called Git branch when you type Kart branch. A branch is just a new history of changes. So branches sort of diverge at some point. You can create a branch when you need a branch. Unlike branches and trees, branches can actually join back up later. You can merge them together. It might be kind of hard to explain why you'd use this feature for people who haven't used Git much. And the answer is, well, actually, you don't have to. If it's just you working on your own repositories, you might not want to. You might just want a linear history. Every change you make comes after the change before it, and that's fine. But if you are working with some other people on the same database, this can be really helpful, because you can go off and work on your own changes for a while on your branch and come back in a few days and see what someone else has done in the same time and merge those back together without getting in each other's way. Of course, at some point your branches need to come back together, usually, and so you can do that. There's a merge command, and it will do its best to merge your branches back together. Sometimes there are conflicts. If you both worked on the same features, then there'll be various kinds of problems that can happen, and Kart will also has some tools to help you with those problems. It's an unusual situation, I gotta say. It doesn't happen that often. So I won't bother going into that, but there are some tools that will help. Right, and if you're working on if you're seriously collaborating on some data with a few people, you'll probably want to stick your repositories on a server. You don't have to. Git is a decentralized version control system, which means you could just push your repositories to your coworker's machine on the desk next to you if you set up your permissions right. So you don't need a server, but it's easier if you have one. Kart pushes things and pulls things around in exactly the same way that Git does. And what that means is that you can use GitHub if you want to, or any other Git hosting service, GitLab, Codeberg, whatever. So there's nothing special required on the server, and I say that with a little asterisk next to it, which I'll come to in a minute. So we'll get into some of Kart's more crazy features. Here's a LINS dataset. It's nationwide. It has 80,000 features, which isn't really even one of their bigger datasets, but I'm just using it as an example. It's a big, it's a big thing, and if you're doing a local project, you probably don't need all of those 80,000 roads. Suppose, for example, you're interested in doing a vineyard crawl on Waiheke Island. So we want to get the data about the roads, maybe for routing purposes or whatever. But we only want a tiny fraction of that huge nationwide data set. So if we can grab our area of interest as a polygon, well-known text, or I think we even handle other, well-known binary hex or whatever, we can pass that along to Kart and say, actually, I only care about Waiheke Island. So that's a fun command line. I definitely typed that all by hand. Right, we'll just walk through that briefly. So Kart clone downloads the repository from a server. So we're saying, I want this repository from the server. It's lins/nz roads addressing to. But I also want to spatial filter it, and here's a polygon. That polygon is the box that I showed you on the previous slide. It's a box around Waiheke Island. But just give me that data, please. Don't download the whole repo. And just to avoid that big command line, you can also actually put your region in a file and reference it. Most of Kart's arguments, things that you tell it on the command line, can be stored in files if you need them to be, just to avoid that kind of verbosity, especially if you're reusing the same region more than once. So that's going to download the repository, but only a little bit of it. Now I'm just going to come back to my asterisk before, where I said you can use any Git host. You can, except for this feature, where the host actually requires some extensions so that it can give you the spatially filtered object. I'll point out that there is nothing proprietary. It's open source. It's in our Git fork. And if you want to build your own server that can handle this, you can do that. But at the moment, the only implementation of that I'm aware of is our one. But you're welcome to fork it and make your own. And Kart will just reject you if it doesn't work. It'll say you can't do that with this host. Anyway, the result is this. Instead of getting the whole data set, we get all the roads that touch that box that we gave it. So we only got the features we needed for our vineyard crawl. And that means it was probably a lot faster to clone, especially with the really big repositories. And it will use less space on disk. Kart can also do shallow clones. This is actually a standard Git feature. We didn't do anything for this really, apart from pass the option along to Git. But there's 400 odd commits in the history of the repo, but maybe we don't care about the history of the repo and we just want what's there now. So we can say --depth 2, and it will just give us the main branch with the last couple of commits and not bother downloading the rest. You can use those together and it'll really drop the size of what you're downloading. So this can be used for some quite large repositories, and if you don't want to download 50 gigs of data and take an hour to do it, you can use these to good effect. Cool. I'm going to gloss over this a little bit. I know we've done talks on this in the past, but Kart does also support raster and point cloud datasets. So if you have a big tiled raster dataset, maybe it's got 1,000 TIFFs in it, you can import that into Kart and push it around. And the same with point clouds. We handle LAS 1.4, although we make sure it's stored as LAS to save on disk space. And Kart is a little bit opinionated about this, and it will try and encourage you to use cloud optimized formats. So on import, it will quite happily convert everything to cloud optimized point cloud or cloud optimized GeoTIFF. You can opt out of that, and it does take a while to convert that stuff and uses a lot of CPU, especially if your data set is big. So you may want to opt out of that. Depends on your use case. And Kart enforces the use of Git-LFS, which is large file storage. So when you push your point cloud to a server, you're going to need somewhere to store your files. And we have one of those services, but you can use any LFS server for that. Yeah. Right. So when you typed that massive spatial filter command line, you might have noticed that that's actually pretty ripe to have a GUI in front of it. And so we built a GUI for it and everything else. So there's a QGIS Kart plugin. You can install it from the QGIS plugin manager. And it supports almost everything that Kart does. It doesn't handle raster and point cloud datasets just because we haven't got around to updating it to do so. There's no fundamental reason it couldn't. But other than that, everything you can do with Kart, cloning things, pushing and pulling, and logs and diffs, spatial diffs, all that stuff is supported by the Kart plugin. So it's quite useful. Also GPL, so yeah. Right. In building this thing, it's turned out to be quite difficult, I've got to say. And we've had to tackle a bunch of problems and challenges along the way, so I thought I'd just point out what some of those are. One of them is that Git is really not built for this. Git was built for the Linux kernel to be, and it's obviously been used in lots of other code projects. The Linux kernel has 11 million objects over its entire history, which sounds like a lot, and it is a lot. Those are 11 million files, or, you can think of it as 11 million files. Kart repos can easily hit that, or much bigger. So we have a data set in a Kart repo, which is over 100 million objects. They are small objects because they're features. But scaling to that has been quite difficult. Git was really not built for this. So about 10 million, 11 million is about where clones start getting really slow and using a lot of memory and CPU on the server and on the client. So that's been a real challenge for us. It was not uncommon with one of our earlier attempts to try and clone one of those things and to be using 50 gigs of RAM and for it to take several hours just to download the repository. That's been improved a lot. We changed the dataset format to work around that. We did a lot of optimizing. The bigger ones are still slow, but maybe not as slow as they were. But up to about 10 million features, it performs pretty well. We are primarily a web development and back-end, services company. We code a lot in Python. We are reasonably dynamic in how we do things. We don't plan things too much in advance. And we have found it difficult to build a desktop app that deals with immutable data structures, things that we can't easily migrate. Can't run a database migration on a Kart repository because Git guarantees immutability. When you commit, the contents of everything in your repository gets hashed, and that hash is the address of that commit. And so that contents can't be changed without completely breaking your repository. And so we've had to figure out how to work with that as a company that's not used to doing things like that. We're generally working with things we can migrate and change later, but this isn't something like that at all. So, we had to write a spec and figure out everything about that spec up front before we could commit to supporting this. So that's been difficult. We built the whole thing in Python because it's a wrapper of a lot of other tools, and Python is great at that. And it's worked out well. We're good at Python. We knew how to do Python. One problem, though, is that the apps that we built with PyInstaller, which is quite good, take about 200 to 500 milliseconds to start. So when you type Kart help or whatever, that's 200 milliseconds gone, which is probably fine for end users, but it's not really fine when you're running it in a loop. And if you Kart, I don't know, maybe you're running a diff on every commit for 100 commits in a loop, and that's going to be quite slow. So that's been a challenge. We've worked around that a bit. We've mitigated it. We can't change how fast Python is to start up, but we did write a little C entry point for it. And the C entry point is able to pass off control to a helper process which runs in the background. So when you first run a Kart command, it might start a helper process, and that helper process might actually take control from later Kart commands. So that when you run this in a loop, it's not taking 200 milliseconds every time. You can turn the Kart helper off, but it'll just make performance worse. Yeah. And many more challenges, but I'll carry on. So I think that's probably just about it. What I would like is feedback from you guys. So if you can go to the website and download it and install it and play around with it, we would really love some feedback from you, because we are, we're trying to build the next generation of it, and we need some advice on what we should be doing with it. Thank you very much.
Okay, we've got time for a couple of quick questions. So has anybody got any questions for Craig?
Hi, thanks for the presentation. I'm just interested in some specs for how to optimize small clouds. How do you store differences? Because they're like one of the main things about them is the off-tree structure, which changes with every change. So do you have some way to calculate the hash of differences of off-trees, or you calculate them? How do you deal?
Questions about how we deal with diffs for cloud optimized point clouds. Yeah, so the short answer is we don't really. If you have 1,000 of them and you change one of them and commit the whole 1,000, we will detect that the 999 didn't change. So we'll just store one Git object for the one that did change. But we don't really, we don't do deltas on the one that did change. We don't store the object is the file, basically. If the file changes, we store a new object. There is a caveat to that. That is, on import, we convert to cloud optimized point cloud, but we also store the original hash of the file before conversion. So that tells us that we don't need to convert these 1,000 files again. We've already got those files. We've got the result of converting those already. So we store the converted hash, but we also store the original hash so that we can avoid importing those files and converting them again if the same files are imported again. But yeah, if the file does change, we will just store a new file.
Okay, one more quick question. In front here.
Sorry, just a question about company resolution, because you showed the if command, it shows the
I'm not quite sure what you mean.
So you showed it, right? And dashboard HTML showed the different two branches, right?
Yep.
I was talking about maybe you have a UI that it shows what feature do I need from each branch.
Yeah.
Not there any conflict.
Yeah. So the where is that? This is a bit small maybe, but yeah, there's a table here and a map there, and if you click on the little thing on the left of the table, it will zoom to that feature, and so you can see there'll be generally 2 features for every changed feature. There'll be a deleted one and an added one, so you can see hopefully the difference if a few points have been moved or something. Does that answer? Kart itself doesn't have a GUI other than this page, but also the QGIS plugin does have a GUI, so it will show diffs in a similar way. Yeah.
Okay, thank you, Craig. Let's put our hands together for Craig's presentation. Okay, we've got a few